The third question is as follows. There's a mirror of length L at an height HM from the floor. Your eye is at this position at a height HE from the floor. This is the floor, such that HE is greater than L plus HM. That means you are standing at a height which is greater than this height. The question is, find the length of the floor which is visible in the mirror, or whose reflection is visible in the mirror. A hint to this question is that you need to consider the concept of field of view, which I had discussed, and that means what? You need to take the extreme rays which gets reflected from these 2 points. So one ray will be like this and the other ray will be like this. These are the extreme rays. So this part of the floor I'll be able to see standing at this point. Okay, so I have given you enough hint. Now you just need to use the properties of similar triangle to find this length F. Let's see. Okay, so proceed. Try the question. Now assuming that you have tried the question on your own, let's see what the solution is. As I said, we need to take the extreme rays because only this portion of the floor will be visible. Any rays coming from this other points will either miss the eye. Okay, now let's see how we use the principle of, or the properties of similar triangle. You know that the angle of reflection is equal to the angle of incidence. So if this angle is theta, this angle is also theta, right? Okay, now just have a look. This is one triangle. Okay, and if this angle is theta, this line is parallel to this line, so this angle is also theta. Okay, this is equal to this angle. Now if I take this triangle, you see what this triangle I am taking, this triangle, and I take this upper triangle. In this triangle one angle is theta, one angle is 90 degree. In this triangle also one angle is theta, one angle is 90 degree. That means these two triangles are similar. So I can say that the ratio of sides are same. So what is this height? This height is, this whole height is HE. HE minus this height. This height is L plus HM. So HE minus L plus HM is this height. And what is this distance? Let's assume that this distance is D. Okay, I didn't tell you in the question that this distance is D. So this distance was given as D. HE minus L plus HM divided by D is equal to, this height is L plus HM in this triangle, and this whole length, let's assume it as X. So I write it as X. So my X I'll get as D times L plus HM divided by HE minus L plus H of M. This is my X. Now I need to somehow subtract this distance, right? If I assume this distance as Y, I need to subtract this distance. So to get the distance F, F is nothing but X minus Y. Okay, so let's do that. Now let's see this point. let's assume this angle is beta, so this angle is also beta because angle of reflection is equal to angle of incidence. Now let's take this triangle, okay, and let's take this triangle. This angle is beta, this angle is also beta. Now in these two triangles, this angle and this angle are same, this angle and this is 90 degree, so I can write the ratio of sides as same. What is this height? This height is HE minus HM divided by this distance. This distance is what? This distance is D. This is equal to this height, that is HM, by this distance is Y. So my Y is what is Y? D times HM by HE minus HM. Okay. Now I have X, I have Y. To get F, I need to just subtract Y from X. So let's do that. If I subtract these two, if I subtract X from Y, I'll get my distance F as D times L plus HM by E minus L plus HM minus DHM by HE minus HM. Okay. The final answer will be DL H of E divided by HE minus L plus H of M into HE minus HM. So this is my final solution. Now let's take one last example.